Welcome back to Mr. Vaughn's classroom. Thank you for joining me for another Algebra 1 lesson. Before we get started, I'd like to ask you to please click the subscribe button if you haven't already. That way you'll get notifications anytime I upload more content. And if you believe that this was helpful to you, if you could give this video a thumbs up so that more and more people will be exposed to this help, and hopefully it'll help them on their Algebra 1 journey as well. Today we're in lesson 4, using function notation to describe rules. This is part 1 of a 2-part lesson. Our learning goal is to look at some rules that describe functions, and we're going to write some functions too. We have 2 learning targets today, so as we go through the practice problems, keep these in the front of your mind. Think about them. Think about how they relate to the problems that we're doing. The goal is, at the end of the lesson, you feel comfortable making these 2 statements, and if you don't, that's what you need to ask questions about so that you are fully aware and prepared when we get to the assessment at the end of the section. Our first learning target says I can make sense of rules of functions when they are written in function notation and create tables and graphs to represent the functions. So this is saying if you are given the rules, you understand what they mean based off of looking at the function notation that is given to you, and you can take that function notation and then create a table of values, or take it and create the graph that represents that function notation. That's number 1. Learning target number 2 says I can write equations that represent the rules of functions. So now they're saying, okay, well, if you're given the rules to the function, can you take that and then write the equation that represents that function? So again, as we go through the practice problems, make sure you're keeping these 2 learning targets at the front of your mind, and at the end of the lesson, if you still don't feel comfortable making these statements or even one of them, please ask for help. With our glossary terms, we're going to start out with dependent variable. This is a variable representing the output of a function. We call it the dependent variable because this is calculated based off of the independent variable that you input into the function. So you're going to take some number for x as an input, you're going to make your calculation, and that number that comes out is going to be your dependent variable or your y. So therefore, whatever value you're going to get for y depends on what value you put in for x. Next, we have function. A function takes inputs from one set and assigns them to outputs from another set, assigning exactly one output to each input. And that is the key that you need to understand. Every unique input or every unique x value is going to have one and only one unique output or unique y value that comes out of it in order for it to be a function. Now, there are situations where the same x can get different outputs, but in those situations, those would not be functions, and that's how you tell the difference. Next, we have function notation. Function notation is a way of writing the outputs of a function that you have given a name to. If the function is named f and x is an input, then f of x denotes the corresponding output. So your function notation is generally going to follow name, in this case, lowercase f. Then you're going to have the input in parentheses, so in this case, x. And sometimes it will say equals, and whatever it equals is your output. Or you can just think of that f of x as representing your output. So you can think of f of x being y. Our next glossary term is independent variable. This is a variable representing the input of a function. So it's your x value. You can pick that x value, so therefore it's not dependent on anything else. It is the first thing that's being picked, so it is independent. Now we begin the practice problems for Unit 4, Lesson 4. Match each equation with a description of the function it represents. So you can see on the left, a, b, c, and d are the functions. And on the right, 1, 2, 3, and 4 are the descriptions, or the rules of what is happening. So the way that I would approach this is to read the descriptions, step by step start putting together what it's saying, and then see which equation you just came up with. So if I look at number 1, the first thing I see is add 4 to the input. Okay, well, my input is x. If I'm going to add 4 to the input, then I have x plus 4. Then multiply the result by 2. So that means I need to take everything that I just did and I need to multiply it by 2. So now I look and I see, where do I see this 2 times the quantity of x plus 4? And I see it right here on B. So that tells me B matches description 1. Now let's look at number 2. To get the output, add 2 to the input. Well, again, we said that the input is x. I want to add 2 to that input, then multiply the result by 4. So I need to take everything I did at first, and I need to multiply it by 4. Now I'm looking over at the remaining equations on the left side, and I see this happen on D. So that tells me that D must match number 2. Number 3. To get the output, multiply the input by 2. Well, we said that the input is x, and if I'm going to multiply it by 2, then that's 2x. Then add 4 to the result. Well, that means I need to take everything that I just did, and I need to add 4. Now I look at A and C, and I notice that A matches number 3. And finally, number 4, to get the output, multiply the input by 4. Well, we said the input is x, and if I'm going to multiply it by 4, I get 4x. Then add 2 to the result. So I'm just going to plus 2. I look over at the left. The only one remaining is choice C, and choice C matches what we just came up with. So that means C matches description 4. If you have any questions about how to match an equation with the description of that equation, please ask for further clarification, whether that's in my classroom or by dropping a comment, and I'll get back to you. Our next practice problem says function p represents the perimeter in inches of a square with side length x inches. So, perimeter of a square, side length x. So I'm going to draw a little diagram here. I'm going to have a square. Every side of the square is the same. So I have x, 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 and x. And the perimeter is the distance around the square. So I need to add all the sides together. So this becomes x plus x plus x plus x. Or I can write that as 4x. So now they want me to complete the table. Well, if the side length is 0, then 4 times 0 equals 0. Next, if the side length is 1, then 4 times 1 equals 4. If the side length is 2, then 4 times 2 equals 8. If the side length is 3, then 4 times 3 equals 12. If the side length is 4, then 4 times 4 equals 16. If the side length is 5, then 4 times 5 equals 20. And finally, if the side length is 6, then 4 times 6 equals 24. So now we have filled in the table. Number 2 says write an equation to represent function p. Well, we kind of already did that at the top. We would simply say p of x equals 4x. Finally, number 3, sketch a graph of function p. So what I'm going to do is I'm going to put points at each of these columns on the table, and then because a square can also be the sizes in between the whole numbers, I'm going to go ahead and draw the line that connects all of these points together. So we had 0, 0, 1, 4, 2, 8, 3, 12, 4, 16, 5, 20, and 6, 24. And now I can draw the line that connects all these points. And this is the graph of function p. If you have any questions about how to come up with completing the table for a perimeter, if you have any questions about how to write the equation to represent the function, if you have any questions about how to sketch a graph of a function, please ask for help, whether that's in my classroom or whether that's by dropping a comment below. I'll do my best to give you all the clarification you need so that you're prepared moving forward. Our next practice problem says functions f and a are defined by these equations. F of x equals 80 minus 15 times x. A of x equals 25 plus 10 times x. Which function has a greater value when x is 2.5? To answer a problem like this, you're simply going to substitute 2.5 in for x on both functions and then see which comes out with a higher answer. So first, we have f of x equals 80 minus 15 times 2.5. Well, 15 times 2 is 30, and 15 times 0.5 is 7.5, and 30 plus 7.5 is 37.5. 80 minus 37.5 is 42.5. Now we need to compare that to function a. So a of x equals 25 plus 10 times 2.5. 10 times 2.5, because there is 1 0 in 10, we're going to move this decimal point to the right one place, and that becomes 25. 25 plus 25 is 50, so that means function a of x is greater when x is 2.5. Another way that we can write this is to say a of 2.5 is greater than f of 2.5. If you have any questions about how to substitute a value in to two functions and determine which one is greater, please ask for clarification, and I'll be sure to get you the help that you need so that you're prepared as we move forward. Our last practice problem says an equilateral triangle has three sides of equal length. Function p gives the perimeter of an equilateral triangle of side length s. Number 1 wants us to find p of 2. So, we got to make sure we understand a couple of things here. We know we have three sides of equal length, and we know that this is perimeter. Again, perimeter is the distance around an object. So if my side length is S, then this is S plus S plus S, which equals 3 times S. So if I want in number 1 to find P of 2, then that's going to be 3 times 2, which is 6. For number 2, find P of 10. Well, now I'm substituting 10 in for S, and 3 times 10 is 30. And finally, number 3, find P of S. Well, P of S is going to be exactly what we came up with in the beginning, 3S. This function allows us to take any side length and find the perimeter. If you have any questions about anything we covered in the practice problems for this lesson, please ask for help so that I can make sure you understand everything you need to before we move on to the next lesson. Thank you for joining me in this lesson. If you haven't already, please hit the subscribe button, give this video a thumbs up, and I look forward to seeing you in the next video.